Alright guys, so we want to use the Morse theorem to obtain the expansion for cos 3 theta and sin 3 theta. So how do we do this? We need to apply the knowledge of our the Morse theorem. Now the Morse theorem, as you know, is that for z is equals to r, cos theta plus I sin theta. Okay, and we have established in one of the videos that z raised to the power n will be equals to z raised to the power n and cos theta plus I sin theta raised to the power n will peradventure give us r raised to the power n. Then we'll have cos n theta plus I sin n theta. So we've established this in one of the videos. Ensure you watch it. Now we are dealing with 3 theta. So what we want to do is, to get this straight, we will implement the power of 3. So we are going to be using just these two. We're going to be using this part of the equation, which implies that this can cancel this, right? This can cancel this. Then I will have just this to deal with. I can have cos n theta plus I sin n theta. Okay, so for this side to be equal to cos theta plus I sin theta to the power of n. Okay, so we are making use of this before we can implement the solving. All right, so having done this, our power here is 3 because we are dealing with 3 theta. So I will say that cos 3 theta plus I sin 3 theta, okay, is definitely equal to writing cos theta plus I sin theta to the power of 3. So we start from here. We are going to start the journey from. So let's clear the other part so we can have enough part to work with. So starting from here, I will then have cos 3 theta plus I sin 3 theta, okay, is equal to, if I should expand this one using Pascal triangle or by using the idea of my binomial expansion, which I have taught in one of the videos, make sure you watch it to have full context. I will be having cos cube theta, okay, plus 3 cos square theta I sin theta, okay, plus 3, as this one reduces, the other one increases, I sin theta to the squared. Then I'll have plus I sin theta cube. Okay, all right, so we expand that one. Since we've expanded that one, we're going to bring it into normality. We have this 3 theta plus I sin 3 theta now is equal to what? Cos cube theta, right, plus 3 cos square theta I sin theta. I square here, if I open this bracket in this part, if I open this bracket, I square will be minus 1, so this one will be minus 3 minus 3 cos theta sin square theta. Okay, that one I sorted it out. Then if I should open the bracket for this one, for this other one here, I will have I cube sin cube. So I cube actually is minus, it will be minus I, okay, I cube, because if I should do I squared times I, then I squared is minus 1 times that is minus I. So instead of writing plus sin I raised to the power 3, I'll just write my minus I sin cube theta. Okay, so I haven't done that, I can now group them. The one that have I or the one that does not have I, I'll group them into themselves. I will have cos 3 theta plus I into sine 3 theta, okay, is equals to, let me bring the one that doesn't have I all together. I'll have cos cube, okay, then minus 3 cos theta sine square theta. These ones don't have I. Then plus, let me factorize my I out because of the one that I have I. So I have I outside, then I will have, so if I want to pick this one first, if I pick this one, I will have 3 cos squared theta sine theta, okay, then I pick this one minus sine cube theta. These are the ones having I. This one's here, they have I. So now I want to find for cos 3 theta first. Cos 3 theta. Now there's something we call equal complex number. I've taught that in one of the series in this complex number. It means that you match the real part with the real part of the other side, then the imaginary part with the imaginary part of the other side. So I want to find cos 3, which is this one here. It's actually standing for the real part because it doesn't have I. So therefore I can match this. I can match this one here. I can match it with this part because this one also stands for the imaginary part because there's no I here. This one having I is the this one is the real part, then this will be the imaginary part because it's having I. So for me to now implement the knowledge of my my equal complex number, I will just say, that, watch this, I'll just say cos 3 theta is equal to what? Just the real part, cos cube theta minus 3 cos theta sine square theta, since this is just the real part. And if I want to match the imaginary part, I'll just say sine 3 theta is equal to what? 3 cos square theta sine theta minus what? Minus sine 3 theta, because this one here, it represents the one that has I, which is the imaginary part. This one here, and this is the real part. Then I can also get what I want to get from here. If you decide to leave your answer like this, you are not wrong, or like this. And if you decide to spread it across, make it in the terms of cos, you are also welcome. So let's make this to be totally in terms of cos. So in that case, let's make this in terms of cos, the first one, since we are dealing with cos 3 theta. Okay, so doing that, I will have, let's cut this bit out. Okay. So we know that from trigonometry, sine square theta plus cos square theta, okay, is equals to 1, right? Which means that sine square theta, and the other way will be equals to 1 minus cos square theta, right? So I can, instead of writing this sine square theta in this place, I'll just represent it as what? 1 minus cos square theta. Therefore, I can boldly say that cos 3 theta is equal to cos cube theta minus 3 cos theta into the bracket of what? 1 minus cos square theta. Okay, then what will be cos 3 theta? In that sense, will be cos cube, okay, minus 3, opening the brackets, then plus 3 cos cube. Okay, so bringing this together, this one and this one, they are like terms. So I'll have 4 cos cube minus 3 cos theta. Okay, so that will be the answer for cos 3 theta, right? Expanding it with the Moivre. Same thing, if I want to apply it to sine 3 theta, I will just expand this one and make everything be in terms of sine, still using this one, that means my cos square theta will be the same as writing 1 minus what, sine square theta. Okay, so I'll just apply that in this place. So to have sine 3 theta, my answer will be 3 into 1 minus sine square theta. Okay, then sine theta minus sine cube theta, and that will be 3 minus 3 sine 3 sine. Okay, I still have my sine here, then minus sine cube. So opening this bracket, I will have 3 sine theta minus 3 sine cube theta, then minus sine cube theta. So the both of these are common, these two are common, therefore my final answer for sine 3 theta would be the same as writing 3 sine theta minus what, 4 sine 3 4 sine cube theta. So this one will be the answer for sine 3 theta using the Moivre expansion. I hope this is clear. So that will be all for this video. In the next video, I'll be showing you how to find the expansion for cos power to a theta using the Moivre theorem.